Alright, here we go. Video 6.5 empirical formulas. Okay, make sure you have something to write with and something to write on so you can take notes. Here we go. A new term, empirical and molecular formulas. We're going to start with molecular formulas, even though this video is all about empirical today. You need to know what this is first. So, molecular formula. Alright, definition. A formula that specifies just means tells, okay? The actual number of atoms in a compound. Alright, a formula that specifies or tells the actual number of atoms in a compound. Molecular formulas are what we've dealt with all year long. That's what you always have seen to this point, okay? So, last semester we had to write down formulas such as calcium phosphate. So, Ca3PO4 2. This is a molecular formula, okay? Or carbon tetrachloride, CCl4, molecular formulas. They tell the exact number, right, of elements or atoms that are in the compound. What we're going to look at today is something called an empirical formula. And what empirical formula is, it is a formula, right, that shows the lowest whole number ratio of elements in a compound. Okay, it's a formula that shows the lowest whole number ratio of elements in a compound. Make sure you have these two definitions down. Pause if you need to. The easiest way to understand these definitions is to actually do a couple problems that's on the next slide. So, alright, we're given the molecular formula of C6H12. And I want to know what the empirical formula is for this. Well, molecular formula shows it's the exact formula. Okay, this is the actual formula. Empirical, we can reduce these numbers. Okay, if I look at this. This is a 6 to 12 ratio. Well, if I divided both of these numbers by 6, this would reduce. What would it reduce to? Well, it would reduce to C, if I divide this by 6, 1, and H, 2. This right here is the empirical formula for this formula. Okay? The 6 and 12 can be reduced to 1 to 2. Let's look at another one, N2O6. These both can be divided by 2. And when I do that, the empirical formula turns out to be N1O3. So this is the empirical formula for N2O6. So it's just reduced. Let's look at something called H2O, water. This is the molecular formula. Now, the ratio here is 2 to 1. And it can't be reduced anymore. So the empirical formula is also H2O. So yes, if it can't be reduced anymore, the empirical molecular formulas can be the same thing. So this is empirical formulas. With that being said, we can actually calculate and learn how to find empirical formulas on our own. So here we go. Start with this one. Benzene is a nonpolar solvent used in many applications in industry. A major component of many organic compounds. Has the following percent composition. Okay, I just gave you a bunch of information that's not really needed to solve this. Okay, but this information is. So, look at this word, percent composition. We did this in the last video. So, we're given the percent composition, and it says what's the empirical formula. Alright, I'm going to show you steps on how to do this, and make sure you write them down. Here we go. To find empirical formula when you're given percent composition, step 1. Take your percentages and put them into grams. And it's very simple. Here's what you do. You just write down for carbon 92.3, and instead of writing percent, put gram. For hydrogen, instead of putting out 7.8%, put 7.8 grams and done, step 1, okay? So step 1, just don't write percent, put grams. That one's pretty simple. All right, step 2, convert your grams to moles. All right, so convert grams to moles. How do we do that? Well, gram and mole together, the mole is 1. And for mass, we go to the periodic table. For carbon, the molar mass is 12.0. So I'm going to write down here 12.0. For hydrogen, same thing. My mole is 1. My molar mass is 1.0. So I'm going to go down here and write 1.0. Let's now plug these into our calculator. So 92.3 divided by 12 is 7.69. And for hydrogen, multiply by 1, divide by 1 gives you the same answer of 7.8 moles hydrogen. Okay, so just to go back, step 1, we took our percent, put them into grams. Step 2, convert your grams to moles. All right, here's step 3. Step 3, we have 2 numbers here, okay? If we had more elements, you could have 3 or 4 or whatever numbers, but we have 2. So we have 2 numbers. What we're going to do is we're going to find the lowest number, and the lowest number is 7.69, and we're going to divide everything by that lowest number. So I'm going to divide this by 7.69. I'm going to divide this by 7.69. When I do this one up here, it comes out to be 1.00. When I do 7.8 divided by 7.69, it comes out to be 1.0. Alright? And both of these numbers are approximately 1 each. Alright, so step 3 was to divide by the lowest number that came out to our answers here. Alright, what we are looking for is whole numbers here. And for this problem, they both came out to be whole numbers. That's fantastic. Once we get whole numbers here, we can now find the empirical formula. And here's what you do. This element was carbon. So we put down carbon. We look at this whole number, and that's what the subscript's going to be here. This whole number is 1. We don't write 1s in chemistry, so just C. This element was hydrogen. Its whole number was 1 here. We don't write whole numbers, so we just write H. So CH, this is the empirical formula for benzene. Alright, it's okay. This takes a little practice, so let's do another one. Alright, I got another percentage one. This time we have 3 elements in here, and that's okay. So we start with carbon. Once again, take your percentages and turn them into grams. We got hydrogen. And we've got oxygen. Okay, so step 1, take percentage, turn into grams. Step 2, convert them to moles. So cancel out grams and go to moles for each one of these. Alright, I got gram and mole together. The mole is 1. Mass we found from the periodic table for carbon is 12. For hydrogen, it's 1.0. So 1 here, 1.0 down here. And for oxygen, we have 1 mole. And we have 16.0 grams for its molar mass. And now we're going to plug into our calculator. So 48.64 divided by 12.0. This comes out to be 4.05 moles of carbon. For this one, 8.16 divided by 1 gives me the same number of 8.16. And finally, our 43.20 divided by 16 is going to give me 2.7 moles of oxygen. So that was step 2, convert grams to moles. Step 3, divide by the smallest number that came here. All right, the smallest number is this 2.7. So I'm going to divide everything by 2.7. And what I'm trying to look for whole numbers. All right, 2.7 divided by 2.7 is 1. All right. So this is going to be 1 for oxygen. All right, 8.16 divided by 2.7. For my hydrogen up here, it's going to be 3.02, which is approximately 3. And for my carbon, 4.05 divided by 2.7 gives me, well, this one gives me 1.5. Now, I've got 1.5, 3, and 1. On the last problem, it was awesome. These all came out to be whole numbers. On this one, they are not. So there's another step involved. If these do not come out to be whole numbers or really close like this one, what you have to do is make them whole numbers. And how you do that is you find a common multiple, the lowest one. And so, what can we multiply 1.5 by to get a whole number? Well, if I multiply this by 2, I will get the whole number of 3. But if you do it here, you got to do it everywhere. So, I'm going to multiply this by 2, and I'm going to multiply this by 2. 3 times 2 is 6, and 2 times 1 is 2. Now I have whole numbers here for all of them, and now I can write my empirical formula. This one was carbon. My number's 3 here, so my subscript's 3, C3. My element's hydrogen. My number's 6, so H6. And my element's oxygen. My number's 2, so O2. So my empirical formula for this is C3H6O2. All right, one last problem to look at. This time, they did not give us percentages, they gave us grams. Matter of fact, this makes it even easier. Here's why. All right, I don't have to change the percentage to grams. I've already got it in grams. So, for this one, we just write down the grams. 12.2 grams for nitrogen. And for oxygen, 27.8 grams. And now we do the same steps. So, I'm going to convert from grams to moles for each of these. For nitrogen, my mole is 1. My grams I find from the periodic table for nitrogen is 14. So I'm going to write down my 14.0 grams. For oxygen, it's 1. And if you go to your periodic table, you'll see that oxygen is 16.0 grams. Alright, so we got 12.2 divided by 14. This gives me 0.871 moles for nitrogen. 27.8 divided by 16. This gives me 1.74 moles for oxygen. So, convert grams to moles. Our next step is divide by the lowest number, which is this 0.871. For this one, it's going to give me 1. If I divide by my 0.871 down here, so 1.74 divided by 0.871 is going to give me 1.99, which is approximately 2. Alright, on this one I have whole numbers, so my formula is N1O2, and I have my empirical formula. And this is how you do empirical formulas. So, make sure you wrote those down, and that's how you do it. If you have questions, ask me in class. You can work on the next worksheet on empirical formulas.